Hello everyone, thank you for joining us today. In this presentation, we will discuss what managers should expect from their team in the furniture manufacturing company. I'm your host, Igor Bordowski, and let's take a look what topics do we have to discuss today. As we all know, the success of any organization depends on the performance and collaboration of its team members. We will see how CAD/CAM optimizes your workflow by streamlining production, ensuring precision, enabling design flexibility, integration, better visual, staying ahead with innovation, and better collaboration. Those are the key factors that boost efficiency and elevate your project. So let's take a look at what happened in the past. Usually a carpenter was a single person that handled all the tasks. He understood the customer needs, performed calculation, created drawings, built furniture, and so on. Below you see some schematical chart about stage of the process, how much time and effort it took. As you can see, it required quite a high skills, so the furniture production took a lot of time because of the reasons that we just saw. And of course, it led to high price of the furniture. On the other hand, technology was quite simple, manual tools the most, and the tool price was also quite low. Nowadays, situation changes drastically because responsibilities were divided among different participants of the process, designers, engineers, accountants, etc. What we can see that because of the specialization, skill requirements shrinked a little bit. Production time shrinked a lot, and of course it also pulled the price. And how we achieve that, we use very advanced technology and very advanced and priced tools. And our focus should be to load those tools as possible with the data. So now the paradigm changed to data management, okay? Because now many individuals are involved in the process. You should be able to create accurate data, exchange it, and manage this data efficiently, okay? Because this becomes a critical factor that connects people, processes, and technology. Okay, now let's take a look at two different types of companies. Abstract mass production factory on the top and a custom furniture factory on the bottom. Of course, the mass production company is interested in producing most common standardized furniture using some unified solutions. The styles are not very broad, but they are popular, and main focus is to make it as efficient as possible. On the other hand, custom furniture factory provides tailored solutions. It focuses on unique designs. It offers many choices, how those materials and designs combine. Now let's take a look at the mass production factory once again through the prism of data. So we have different departments, research and development, we have factory and distribution network. Okay, so what happens on the R&D? We analyze market demand and we do some designs. The most popular designs are developed. In the factory, of course, the manufacturing process starts from the data preparation for the manufacturing. We have some manufacturing orders, we do the manufacturing process, and finally those units goes to the warehouse. And then from the warehouse, they are spread across showrooms where they are sold. When the deal is closed, some feedback can be sent back to R&D. And this actually guides their further development. What is interesting in this situation is the fact that factory can work on its own. Yeah, if there's like a huge production series, so the factory can work like entire month on building some set of furniture design, which is common on the market. The design process is not directly connected to sales or manufacturing. It's not critical. For the same reason, design time is not critical in the entire process. If you build the same furniture for an entire month, it doesn't really important how much time you spent on the design. Let's say 5 hours or 8 hours. Okay, you need to refine it as much as you can. That's the key point, because if you made mistake and you multiply it by amount of units, that's a big problem. CNC program development is also out of the design cycle because it happens in the factory. The automated bomb transferring to the ERP is less important as well for the same reason. You can do this in semi-manual manner, time is not critical. However, the warehouse management is, because you need to know how many units you have left in a warehouse, can you supply them to the showrooms, and so on. In this case, we have some moderate data reuse. Okay, so we're looking for previous designs and we're trying to reuse them as much as we can. Now let's take a look at the custom production. You can see that positions switched, and up front we have design consultant, because in the custom production, design is critical. It starts from the requirement analysis from the customer, then we do design project, And finally, when it's approved, only after that, factory starts to do something. So it analyzes design requirements, makes some engineering, because you need to differentiate the designs from engineered data. Okay. We'll speak about this later. Now, when the engineering data is processed, we get some manufacturing data set, like say drawings, CNC files, and so on, transferred to the manufacturing order. Okay. And actually, manufacturing process is happening. And after all, the furniture is delivered to the customer. So in this case, design process is closely integrated with the sales production workflow. Actually, the production workflow is not possible without the design, and time is also highly critical. In order to achieve that, you need to use as much legacy data as you can. It's not that easy to do because furniture units are custom, but nonetheless, you can still reuse some pieces of the furniture, let's say drawers, maybe some cabinets, with different facades, but nonetheless the structure could be the same. Technical documentation is not so detailed because it's mostly used for the single case. CNC process development should be highly automated because in this case, if you spend a lot of time on manufacturing data preparation, that will be a bottleneck. For the same reason, BOM transfer to the ERP should be also automated. Now let's take a look at the time proportions. How much time in percentage we spend for the design. And you can see that a mass production furniture company spent way less. For the custom factory, you spend time for each unit. Yeah? For the mass production, you spend for one table and then you make thousands of them, right? Manufacturing data, nearly important, but a bit more important in the mass production. The unit manufacturing time is way smaller in the mass production for the obvious reason. When you just polish the process, when you develop shortcuts wherever they are possible, then you can go with the highest pace. The unit cost for the custom factory is way higher. And of course, the unit quantity is way bigger in the mass production case. Often, companies combine some things from both departments. It may look like a mass production is more profitable, and actually it is in most cases. However, trends are shifting to the custom materials, custom designs, and so on. So in order to be in this area of the market, you need to also provide some solutions. And here we have an example of one of our customers about the proportion of the production. So you can see they are mostly focused on the standard unit manufacturing. And if you compare designer quantity, you see very opposite situation. 3 designers can fulfill the needs of 80% of the manufacturing because it's standard. But they need to have 4 times more designers on the custom manufacturing. And if you compare relative person efficiency, we can say that standard designer is way more efficient than the custom one. So now let's take a look at some company work processes more in depth. Normally companies are not very happy about showing something special on their workshop, but we found one that is happy to spill the beans. So let's take a look. Here are some hypothetical company which produces both custom and standard furniture, and we will go through the production line and see what goes on in the different stages of the process. Of course, it's very simplified, it's very unified, but nonetheless, we can get understanding to be on the same page. Let's start from the designers. They are guided by customer ideas and preferences, some layout of the room. They also use some catalogs with material definition and constraints. They use sketching and rendering apps such as SketchUp, 3D Max, AutoCAD, and so on. They also use some feedback platforms in order to share data between the customers, get some approvals, and after all, they provide some visual concept with dimensions, some technical sketches, renders, material requirements, and design specifications. In an ideal world, the designer should use the same software as an engineer or vice versa. But as we will see, it's not the case. While on the design stage, it's enough to have some generalized shapes, definition of materials, and so on, some dimensions, of course. Here we need to actually think about how this unit will be technologically built. Engineers are guided by designer's concept, material specification, manufacturing constraints, etc. They use CAD apps for detailing, like say Woodwork for Inventor, SolidWorks, Fusion, etc. All those CAD systems. They also use product lifecycle management and product data management software in order to share the data, to manage the states, and so on. As the outcome, we receive some detailed drawings, dimensions, exploited views, section views. Then we have bill of materials. And of course, we get production files for the CNC and other equipment in order to feed them with the data. It's critical to mention that in woodworking, each part is combined with multiple workpieces Each of them may have oversize according to the grain direction, the edge banding thickness, and so on. You can even face with some composites. They are made of glued workpieces. So in this case, that's the desktop. To get its thickness, we need to glue the frame between two sandwich boards, and finally we apply some veneer on top of that. So you can think that's one unit, but it's actually not. You need to have all that leading information on different stages of the manufacturing of this single desktop. Now let's take a look at the proportions of the designers. Of course, those may vary depending on the factory, but let's take the same example I took just a few minutes ago. Most of the engineer teams are focused on the custom manufacturing. Standard furniture designers' work is a bit different. They're just combining pieces, changing some parameters. On the custom, we need to make everything from scratch in most of the cases. Now let's take a look at accountants. They guided by the BOM provided by engineers, material, labor, and operational costs, and of course supplier information. They use some ERP systems like Accept, Navision, Monitor, Oracle, and so on. As the result, we receive production cost, the cost of the finished product, and total cost of the project. Let's jump to the first floor and see what is going on the manufacturing. When we get manufacturing order, it starts from the warehouse. The guys on the warehouse are guided by the nesting BOM with material sizes, types, and quantities. They also know where to look for because they know the storage location data provided by warehouse management system or inventory management system. Their task is basically to collect all the pieces together. They can use some fancy technologies like barcode scanners, RFID scanners, and so on to confirm the correctness of the selection. And finally, they collect the units and send them further to the next stages. And now let's move to the workshop. Of course, it's a little bit simplified. It's too clean for the workshop. And we start from the beam saw. So this one actually can operate with a different set of data, but the main one is the cutting instruction from the engineer production files. Okay, so it can be a layout or it can be just a list of rectangles. And most of those beam saw software front-end applications can operate with this list of rectangles. They use cutting optimization software like Cutright, Beziworks, Hardis, etc. And the outcome is cut panels. It's important to somehow differentiate them afterwards because by the size, the front panel and the side panel can be the same. So that's why we have labels for the next stages. And the next one will be the edge banding. We got a panel, we identify the panel, we know that this is the correct one. Maybe on the label itself we can have some instructions about what side should be covered with what type of the edge banding, and there we have it. So the operators of the edge banding machine are guided by labels on pre-cut panels. They also can get some edge banding material specification, and they use some edge banding apps for those edge banding machines, and in some cases adhesive and trimming tools. And the outcome is finished panels with the edge banding on them. And then those panels travels to the CNC machine. The operator should identify the panel by the label, by the marking, put it on the correct corner of the machine and run correct program. So when the panel is identified, the operator is guided by the drawings, but the optimal way would be to receive some CNC files right away from the engineer. They are guided by the dimensions of the panel. You can just double check if everything is correct, material properties to set up the approach and withdrawal of the tool because different materials are processed with a different speed on the tool rotation. They use CNC control and optimization apps such as AlphaCam, Woodwop, etc. There are plenty of them. And the final result is machine part with drill holes, grooves, and so on. So basically we get this shape. So now when we have the collection of those panels in the final state, we can send them to the assembly line and there we can have assembled pieces or we can have packed pieces. Both options are available. Of course, the second one is less expensive in terms of transportation and labor cost. The assembly crew is guided by engineering instructions and assembly guides. They use some packing or assembly tools. The packing task is not that easy as it may look like, because you need to know how many parts will fit in this box. You need to stay in some size and weight range. Okay, and there is some 3D nesting, if we can name it like that, software that allows you to just combine those pieces all together. It may be that there is some free room left, so you need to have some cardboard piece or a foam piece put into the package to avoid some accidental movement of that. And the outcome is assembled or flat pack furniture ready for delivery. The final stage is boxes or units delivered to the customer. So now when we are on the same page in terms of what is happening, we can speak about what we can do in order to improve all that workflow. Let's start from the participant of those workflows. In the mass production or custom furniture, everything starts from the designer in both cases. The designer sends the data to the engineer, and when the engineer receives this data, it can be used to produce the data for warehouse mount, beam saw operator, edge bending machine operator, CNC operator, furniture assembler, and of course the accountant. Okay. So if you flip this diagram a little bit, in terms of what data they receive, we can see we are interested on the manufacturing side. So that's why the designer and accountant gone from this chart. So we receive part lists or BOM for the warehouse. We get cutting part BOM for the beam saw operator. We get labels, CNC programs, and drawings. As you can see, engineer is a bottleneck. Not engineer itself, but engineer and the tool that he uses. So we need to think how to improve that. Our human capabilities are limited, so we need to focus on the software that we are using. And often there is a question how to choose a CAD. And compare a CAD system based on a checklist is not a good idea because of the reason you can see on the screen, right? You can find that most of them have the same check marks, because otherwise they will simply not work. So how we can differentiate the CAD system? There are CAD systems that we call template-based or configurators, and they are very quick for furniture that can be predefined in advance, like cabinets, their combination with some dividers, with some facades and so on. That's why those systems usually have some extensive library. So we need to be able to find a unit that we are dealing with and then modify it to our needs. It's quite easy to use for less skilled designers. For the same reason, we can just pull out the data from the library, just change some parameters, and there we have it. And of course, the system automatically provides the manufacturing data. So what is the negative side? Usually a new structure, let's say in shop fitting, you're building something new, requires to making a template file. And to make this template and put it in the library, you need to have probably higher qualification than the other CAD systems, because normally there are some rules, some workflows embedded in those library components. And need to make it perfect, because otherwise your mistake will spread across all the users of that unit. And for the same reason, it's challenging for complex structures. We need to actually define a lot of rules in advance, especially if you have different materials, like say glass, sheet metal, frames, profiles, etc. In most cases, those system doesn't support composite parts and other units of this type. Now let's compare a CAD with woodworking add-ons. The complexity is limited only by the CAD. Limit of the complexity is very high. It can combine all the materials that you can find in the industry, like wood, sheet metal, frame designs, and so on. They also support some libraries, so you can reuse the data, so you can design drawers, cabinet frames in advance. If you have correct add-ons, they will also support multi-layer panels and composites, and you can also prepare manufacturing data automatically, of course. What are the disadvantages? Not a lot, but they are quite important. So they are a bit slower in comparison with template-based systems, but on the other hand, if you do something custom, those template-based systems are also not very fast. And the qualification requirements are higher. The next topic, streamlining of the production. Let's start from the modeling. So what are requirements for the system? You need to make sure that your system is capable of utilizing top-down design. It means that you should be able to start from some concept that later will be refined. Parametrical design systems such as Autodesk Inventor, SolidWorks, Solid Edge, Fusion, and so on support that natively. Template-based systems, say IMOS, etc., they can also do this, but through the different methods. Let's say that we have some general design. We can split this into the blocks, and then we can use each block as a reference for next steps. For instance, if you have a metal and if you have panels, we can just split those and then refine them in different ways. When we have things made of the metal, detailed, and then we have panels with their material grains, other sizes, and so on, we can bring them back together and we can get precise match. And there is some key aspects. So first you need to make some joints in order to connect all that stuff. If those joints doesn't consider the edge banding thickness or maybe some other tiny bits of data in a model, you will fail to assemble that unit. The tolerance can be only guaranteed if the drillings are on the correct place together with hardware. You place the hardware, and if your software is capable of placing drillings to the right spot, that's a good point. Also, you need to make sure that the CAD system you're using is capable of working with furniture materials. So we need to know that each part is a small assembly, can be made of multiple layers or multiple pieces, the other sizes, grain direction, and so on. And all the data should be transferred to the reports, drawings, and CNC programs. On the final stage, we have a complete model. And the best scenario is if this 3D model is used as a source of the data for the next stages. So if you're able to get the bill of material, drawings, CNC, and the nesting files, that's perfect. Because otherwise, you'll get some data flows that are not related with the model, and that will lead to some mistake. You can also improve the workflows if your system supports the API, Application Programming Interface, that allow you to define the output data using some programming directly from the model. And in this case, you can eliminate some intermediate files. Now let's take a look at the drawings. This actually takes a lot of time. Drawings are simple, but you need to include some marking like grain direction, edge banding, and so on and so forth, some technological operation definition. To save time, drawings should be only used for complex parts, and regular parts should be automatically recognized by the software, and the CNC programs should be generated for them without drawings. Still, many companies rely on the drawings for different reasons, for double checking, to find some source of mistakes where they happened and so on. So for quality assurance, the drawings are still important. So that's why it's a good point if your CAD system is capable of delivering automated drawing generation. CNC file preparation takes a significant portion of the production cycle. In most cases, there's some dedicated person, technologist, CNC operator, and so on. Manual CNC programming is based on the drawings, and there's a risk to get a bottleneck situation. It's also the risk to get some mistakes. The best scenario would be to recognize technological operation based on the geometry, regardless of how this geometry were made. So you can just made it in a different way. You can import this geometry from another CAD system, and your CAD should be able to recognize the technological operations. Now let's take a look at the recommendations. Best scenario would be that if your CAD would be able to extract manufacturing data from the model directly. You should be able to use some analysis tools. Those are vary. For instance, you can get some warning messages if the size of the part goes beyond the limit. But the best of those are visual. If your model can visually get some clues that something is wrong, like intersection analysis, for instance, if those panels are overlapping, if you get some warning about that, that's the best way. You should reduce manual input because of the side workflows. When the person manually enters the data, when you get some BOM, then you get some drawings, CNC files manually generated. So those not only reduces the time, but they also reduces the quality of the data. Each of these transfer actually leads to potential problems. And that goes to the next step, because if you do some changes, those should be done on the design. And when the design is changed, when the model is changed, the changes should be reflected in manufacturing data. In ideal world, you need to standardize design workflows and the data formats. So each designer should produce the data in the same way. That leads to a capability of exchanging the models. If you get some other design, and if you're not able to understand how it was built, you start from scratch, right? That leads to a loss in efficiency. You need to regularly update the software, and you need to perform the trainings on this newly updated software. It may look like some unnecessary routine, but it's not, because software actually develops very rapidly in most cases, and the workflows that were popular, say, 10 years ago are not relevant nowadays. In order to control all the data, you need to use PDM, because it's nearly impossible to do this correctly. Say if you try to do this using cloud data storage and so on, because they not control the access, they not deliver some critical restrictions for the data overwriting, versioning, and so on. The last one is to reduce the paper documentation for the obvious reason. Of course, we need to save the planet. That's one of them. But the other is to have updated data all around. So if you have paper drawings lying on a table, if the changes happens on the design, you don't know about that. But if those drawings would be in digital form, you'll get an update. Okay, now let's take a look how we can achieve the precision and quality. There are different workflows, but let's take the traditional one as example. And this workflow is sequential. The model is used to produce drawings, then the drawings is used to produce the BOM, and the drawings with the BOM is used to produce the CNC file. The problem is that if we do some changes in the middle of this chain, then chain links actually breaks. They are not related any longer. Ideal world is that your 3D model allows the designer visually evaluate the structure, verify its correctness, and then you need to be able to place holes with the hardware all together. So basically what you see in the model should be delivered in the BOM CNC in the drawings. Okay, the model is a single source of the data. If something changes, you need to do this in the model, and all the manufacturing data should update. What are our recommendations? You need to use a CAD system with embedded validation tools. You should prefer a CAD system capable of top-down design. Maybe you don't use it all around. Maybe you use some data from legacy designs. Nonetheless, if you do something new, then top-down design is a must. Of course, the hardware placement and hole generation significantly reduce the time and increases the quality of your model. If your CAM system is capable of recognize model features instead of manual input, that's another improvement. You need to test design before manufacturing. That's a critical step. So what your software is capable of delivering, that's another question that you need to discuss. Of course, you need to employ the ERP system to manage and track the production data. If your ERP is capable of delivering some automated reports, that's a huge benefit. And of course, you may want to use MES systems to monitor manufacturing process in real time. But ERP and the MES systems requires a lot of data. Yeah? So if you want to get process in real time, imagine that someone need to feed those systems with the data. And if you do this manually, that will be another bottleneck. So the higher automation is a critical point for those ERP and the MES systems to provide some reports, because otherwise it will be a bottleneck. Now let's take a look at the flexibility in design and materials. As I already mentioned, there is a growing need of delivering custom furniture with custom materials and custom design. So your CAD should be able to deliver custom shapes, custom materials, and so on. Of course, if you assign the materials but you're not able to deliver the BOM from that unit, it's not a good situation. So your CAD system must be able to read that combination of glass, metal, and so on, and deliver it to the manufacturing data preparation. Okay, what are our recommendations? You need to adapt to the modern world where we have very short production series and growing demand for the custom designs. We need to prefer a CAD system which can handle that. But on the other hand, despite that our CAD should be able to handle custom designs, we need to standardize the workflows. So the more standardization happens in the workflow, the easier it would be to share the data and reuse the data made by others. And for the same reason, the CAD system should be capable of working with the libraries. Standardized components, the more you reuse, the less time you spend, the less is the chance to make some mistake. Variety of materials dictates the need to work with paints, veneer, composite panels, steel profiles, glass, plywood, and so on. During the design stage, you need to be able to work with all the important furniture-related data such as oversizes, grain direction, and so on. And all the data should be able to be delivered automatically in the manufacturing stage. And of course, this data should be automatically shared with other participants. Speaking about the integration across the system, important point is to understand that CAD system doesn't work in isolation. It have input data and it have output data. Basically, we need to consider how flexible we can generate different reports. You should be able to tweak the output file to provide the data as an input to other IT systems like ERP, MES, and so on. On the other hand, CAD should be able to retrieving the codes from those systems. And that's actually crucial to ensure a seamless information transfer between the CAD system and other IT systems. So what our recommendations are in this regard? You need to recognize CAD as a vital component of your workflow because it produces the data for downstream systems. And you need to choose a CAD that seamlessly connects to ERP, MS, and other systems. And it should ensure bidirectional data exchange. Let me explain what I mean. It should be able to get ERP data, say material codes, names, and other parameters, before a BOM generation, and then it should be matched with the amount of material. So you have 10 square meters of material with such code, such name that is known for the ERP system. You should be able to transfer this model-based BOM with the codes and quantities back to ERP or MES. To ensure the capability of making some tweaks here and there, reports that are flexible is very crucial. If you just get static reports without any tools to tweak them, it's very hard to do all those connections. Let's speak about better visuals and communications. A CAD system offers two main representation: wireframe and rendered views. Normally wireframes are some legacy stuff like from AutoCAD era, so when we had just the lines. And now modern systems should offer real-time rendering views, cutting planes, photorealistic visuals, and so on. It's not only for like a visual appearance, but in most cases, the designer or engineer should be able to actually perceive all these, shadows and so on, other information, especially for shop fitting, etc. Quality and the customizability of the drawings is also a key factor, especially for assembly drawings. Your CAD should be able to deliver section views, detailed views, BOMs, and so on within the drawing. And in ideal world, those drawings should be related with the model. If you change the model, the drawing should be updated automatically, because otherwise we get a broken link. What are our recommendations? You need to choose a CAD system that supports wireframes, section views, lighting, shadows, reflections, and so on. You need to prefer the system that is capable of using GPU for the rendering. It's way more efficient. Views should be model-based, customizable, and so on. In some cases, the views generated on the CAD system can withstand the views generated by designers, say in 3D Max or in Blender, at some degree. Of course, they will be not that photorealistic and so on, but it depends on what you are solving. Yeah, if you do some lighting analysis and so on, maybe they will be not sufficient for this task. But if you just need to show the general ideas with some realistic materials, they can deliver that. Also, the good point is to deliver clear assembly instructions. Some CAD systems even allow you to do some animation about how those pieces should be assembled. Or at least they should be able to deliver presentation view when those parts that collected into the assemblies can be just moved aside, and then you can just see where they go. Of course, CAD data in most cases is not used only by engineers. It can be used on the workshop and so on, and those persons should also reach reliable, updated data. And for this reason, in the ideal world, you should look for the CAD system which supports some viewers or thin clients that allow other participants, non-CAD users, to reach CAD data. Sometimes it's hard to make everything from the first try, so it might be like a versioning question. Yeah, so you should look for the system that supports version control and change management. Now let's move to the next topic about staying ahead of innovation. Probably there is no person which didn't heard about the AI, right? There are different kind of AIs even capable of getting 3D model if you make a single picture. There are systems that can rebuild a 3D model from multiple pictures, that's true. They can just build the point cloud and so on. But nowadays, you can get the 3D model from the single picture. Yeah, you can see the trends for generative design, 3D printing, and so on. So who knows what will happen in the next year or two. So we need to stay on track. When you select the CAD system, you should also consider how often it's updated. You need to include those update costs in the budget. Yeah, there are different licensing models, but the trend is to move to the subscription. And one of the benefits of the subscription is to get newest and greatest software. The CAD system doesn't work in the isolation, not only on the single factory, but also in most cases we get some input data and we need to send some output data in a different format. So the success depends on how your system can handle different formats. And the more, the better. You need to accept the fact that we are living in a constantly changing world, and we need to check our CAD provider about the update policies. And you need to include those update expenses in your financial planning. You need to also include hardware upgrade or update expenses in your budget. If you're working with the imported models or different formats, the good point would be to choose a system that can recognize model features designed in another CAD. So for instance, if you got the model and you want to remove some drillings, change the position of them, the great situation would be if you just be able to recognize those features and change them. Because usually when you import the data from another CAD system, you don't have any controls. You just get the geometry without the history, how this geometry is built, without the parameters to control the size and so on. So if your CAD can recognize the features and allow you to change them, that's a great point. And in most cases, we are working with some architectural data nowadays, especially when we do some custom designs. So it's also an important point to check how your system handles the architectural CAD data. In the larger teams, efficient collaboration is a key. You should be able to exchange the drawings, the models, the bombs, and so on. But the problem is that when you work alone, you know what is happening on your computer, right? If you need to work in the team, your team members doesn't know your rules and vice versa. So you need to have some processes defined, some rules of modeling and rules of searching the data. And if it's done correctly, you can find the data that is done previously by your colleague and use it in your work without spending a lot of time. So pairing your CAD system with the PDM solution is crucial in this regard. What our recommendations are. Your CAD system need to be able to support both parallel and sequential top-down design processes. Parallel is when you have like a huge structure, let's say you do shop fitting, and you can split, let's say a left part of this shop is done by you, the other one is done by your colleague. Sequential is when you do one step, when you do some refinement on the blocks and so on, and your colleague refine those blocks. So in the real world, your CAD system should be able to support both. The second point is that your CAD should meet established conventions, because otherwise, if there is chaos in your workplace and you share it with your colleagues, that will lead to like exponentially grown chaos across the company. In ideal case, the furniture model should be a single source of manufacturing data. In order to control all the changes, you need to implement change management control, integrate CAD with the PDM, and you need to utilize the PDM tools, because there's not just a saving CAD data tool, but it's also allow you to find the data using different search criteria and so on. And if you are able to find the data, you should reuse it. You should reuse existing proven CAD data wherever it's possible, not like one by one, but you can use it in order to make some changes and actually fit it in your design. Now let's compare universal CAD system and specialized system tweaked using suggestions that we showed previously. If you compare the modeling, we can see some strange situation here. On the modeling stage, it may take more time than in a universal. Why it happens? Because on the next steps, when you say prepare the drawings, the data that you entered in the modeling, say the edge band in grade direction, can be also displayed in the drawing as well. The same rule goes for the BOM. If you added some extra bits of the data in a model, this can be also extracted in the BOM of specialized CAD system. Last but not least is the CNC. So if you're able to extract the technological operation from geometry, is great. And the most important point is the time saving. As you can see, you can get a huge time saving using specialized CAD system. And if you multiply, like say, let's imagine like 2 hours a day, and you multiply it across the company, that's a huge time saving. Now let's just briefly look at those points that we already discussed. We covered how CAD-CAM improves your workflows, how you can streamline the production, achieve better precision, flexibility in design materials, integration across the systems, how better visuals and communication can help you spread the data across the collaborated teams. And of course, you need to stay ahead with the innovation to be competitive. In the conclusion, I want to say that CAD is just a tool. So the CAD performance relies not only on the software itself. Proper implementation, integration with the other tools, and support is critical. If you define the workflows correctly, if you develop the rules of work, this actually ensures way higher efficiency and productivity. And the success also depends on the aligning technologies, process, and user experience altogether. We scratched the surface of those important questions. We are limited in time, so that's why we were not able to go very deep. So if you need a tailored recommendation for your business, feel free to contact us. using the email provided below. And I want to thank you very much for your time, and I hope to see you in our next events. Thank you very much and have a great day.